Hello dear learners, this is Zamir Shekh. Welcome you all in this video lecture. Today I am going to teach you one of the principle in which is used in quantum chemistry as well as in the spectroscopy, that is Franck Condon principle. So according to this principle, this is a type of a rule which is applicable to find out the intensity of vibronic transitions. So vibronic transitions are generally occurred during the electronic transition. Whenever we are doing electronic transition, the vibrations are also be occurred because each electronic energy level is comprises with different vibration energy levels. Okay, so we will move to one by one. So first of all what? So this Franck-Condon principle is a rule which is used in spectroscopy and in the quantum chemistry. So this rule which explain the intensity of what vibronic transitions. It can be explained the intensity of what vibronic transitions. What are the vibronic transitions now? Vibronic transitions are a simultaneous changes in electronic and vibration energy levels. Electronic and vibration energy levels. Okay, within a molecule. Okay, within a molecule. So due to the what? Absorption or the emission of photon of a appropriate energy. So basically, during the electronic transition now here, so I will show you the spectrum or molecular energy level. Particularly this is electronic energy level, ground state electronic level energy level, and this is the first excited energy level, and in that there are many vibration levels are also be present. Okay, so let's say this is a V0. Okay, and during this electronic transition, for example E0 to E1, so there are many vibration levels are crossing. Okay, and so whenever you provide some light, so it will undergo the transitions from what E0 to E1. So during the electronic transition there also be vibration, there will also be change in vibration energy level. Okay, and so basically this rule is applicable to find out the intensity of vibronic transitions. Okay, let's move to the another portion. Like, so vibronic transitions are a simultaneous changes which are occurred in electronic and what the vibrational transitions levels. Okay, vibration levels particularly within a molecule. So when it occurred, whenever there is a absorption or emission of the photon with an appropriate energies occurred. Okay, this one. So during the electronic transition there is also be change in vibration energy level, as we see in the molecular energy level diagram. So this is another diagram which showing many vibration levels are overlapped. Many vibration levels are overlapped during the electronic transitions. Okay, and that transitions are called the vibronic transitions. So we will see first one. This is the diagram that's called the Franck-Condon principle diagram. So this one is most important, since the electronic transitions are what? Are very fast, because we are providing more energetic light, okay, than what the your nuclear motions or than what your rotational motions. Okay, so electronic transitions are always very fast compared to what the other type of the motion, because it is an energetic one. So then classically how can we stated this Franck-Condon principle? Classically the Franck-Condon principle is the approximation which explain the electronic transitions. Okay, or during the electronic transitions which is occurred, okay, without any change in, or during the electronic transition without change in the position of nuclei in a molecule. That means during the electronic transitions the remaining portion, that is a molecular geometry or your molecular that is a position of a nuclei, they are always remain unchanged. Okay, so only the electrons are excited from one to other level. Okay, fine. So the resulting state is called the your Franck-Condon state, and intensity of what vibronic transition is proportional to what the square of overlap integral between what the vibrational wave function of any two levels in which the vibrations are occurred, and ultimately we are can be summarized with the help of this one. So intensity of vibronic transition states directly proportional to what the integral wave function of what the any two vibrational levels. So and finally that I is intensity, Vt is a vibronic transitions where it occurred, psi is a wave function, integral wave function, and the del E is a any two vibration levels in which the vibration in which the transitions are occurred. Okay, so in this way, this is very interesting applications of what your Franck and Condon principle. Generally it is used in the electronic spectroscopy. Thank you, stay connected.